2.57, each of the following elements is capable of forming an ion in a chemical reaction. By referring to the periodic table, predict the charge, the most stable ion of each. In letter A, it's magnesium. Magnesium is in group 2, and group 2 almost always forms positive 2 ions, so we put Mg plus 2. Letter B, aluminum. Aluminium is in group 13, and they almost always form positive 3 charges. As a matter of fact, on next year aluminum, you might have a plus 3. Next, we have potassium and letter C. Potassium is in group 1. Potassium in group 1 always has a plus 1 charge, so a plus 1. And then we have letter D being sulfur. Sulfur is in group 16, and group 16 is almost always minus 2. So we'd put a negative 2 right here. And letter E, fluorine, the element fluorine is in the upper right-hand corner. It's in group 17, and they're almost always minus 1. So a negative 1 right here for fluorine. That completes 57. The last one is number 64. 64 says complete the table by filling in the formula for the ionic compound formed by each pair of cations and anions as shown in the first pair. So you can see here sodium and oxygen went together to make Na2O. So the next one would be sodium and nitrate. You'll notice sodium's positive 1 and nitrate's negative 1, and so we'd end up with NaNO3. Notice how I always put the cation first. The positive ion goes first, then anion. In the next one, Na would go together with SO4, but notice SO4 is minus 2, so I'm going to need 2 of these positively charged NAs to partner with the SO4. In the last one, Na, notice it's positive 1, and ASO4 is negative 3, so that means I'm going to need 3 of these positive 1 things to make that formula. The next one, calcium would go together with oxygen, positive 2 and negative 2, so it would just be CaO, because the plus 2 and the minus 2 cancel each other out and they add up to 0. This next one, calcium, would go together with the nitrate right here, and notice that calcium is plus 2, the nitrate's minus 1, so I'm going to have to indicate that there's 2 of these minus 1s here by putting parentheses around and making it be CaNO2. Then calcium would go together with sulfate. Notice calcium's plus 2 and sulfate's minus 2, so they just go together with no subscripts. And the last one, calcium is positive 2, arsenic is minus 3. And so I'm going to have 3 of these positive 2s to give me a plus 6, and 2 of these negative 3s to give me the Ca3ASO4 formula. The next one has iron in it. That would be Fe positive 2 and oxygen negative 2, so FeO. The next one would be FeNO3 2, because there's 2 needed for 2 of those nitrates, because iron is plus 2. The Fe would go together nicely with the SO4 because Fe is positive 2 and sulfate is minus 2. And in the last one, we would have a positive 2 Fe going with an ASO4. I would have to have 3 of these Fes and 2 of these ASO4s, because this times 3 would give me negative 6, and this times 2 would give me positive 6. The last column right here, aluminum would go together with the oxygen. I would have to have 3 of the oxygens and 2 of the aluminums, because that would give me a plus 6 charge right here and a plus negative 6 charge right here. The aluminum would go together with the nitrate, saying that there are 3 of these negative species to go with one of these positive 3 species. The aluminum would go together with the sulfate, and I would have to have 3 of the sulfates and 2 of the aluminums. 2 times 3 gives me positive 6. 3 times negative 2 gives me a negative 6, and those would match. And then the last one, Al would go very nicely with ASO4, because this is positive 3 and this is negative 3, and they would balance each other out.